Hello, everyone, and welcome to the OCX Webinar Week. My name is Ludmila, and I'm happy to have you all with us. This week, we are celebrating the lead up to OCX 26, our flagship event happening in Brussels in April 26. It's the place where the open collaboration community meets to connect, learn, and exchange ideas. If you haven't registered yet, you can find the link in the chat. We'd love to see you there in person. Now, I would like to give the floor to my colleague Perry, who will briefly present sponsorship opportunities at the OCX. Perry, you have the floor. Thank you so much.
Thank you for the introduction, Ludmina. Hello, everyone. I just wanted to quickly highlight a few my apologies. I just wanted to quickly highlight how your organization can get involved in OCX 2026 in Brussels. We have several sponsorship options available. These options will provide brand recognition, reaching over 600 professionals in many industries within the open source community. Through our 5 co-located events, you and your organization will have the opportunity to meet new and existing members of the community, including developers, decision makers, and ecosystem leaders. There will be several social activities throughout the conference where your team will have the opportunity to enhance existing and build new relationships with other organizations shaping the future of open technologies. At present, we have 5 levels of sponsorship and several options for add-ons. Each sponsor will benefit from the visibility on site, online, and across our community channels leading up to and during the event. Each sponsorship level includes a list of benefits. Some include a booth and or speaking opportunities, and our higher level Diamond and Platinum sponsors also receive additional exposure by sponsoring a specific co-located event for targeted visibility in their field at no extra cost. It'd be really great if you could pass this information on to your marketing team. I would be happy to reach out, book a meeting, go over the opportunities in more detail. I believe Ludmina will provide an email that you can reach out to, which I will receive, and will be happy to book a meeting or provide you with any details about sponsorship and moving forward with it. Thank you all, and do enjoy the rest of the webinar. Thank you.
Thank you, Perry.
Thank you so much, Perry.
Thank you.
Okay, now, just one moment. Thank you so much, Perry. So today I'm very happy to present our colleague, Frédéric, who will be talking about the Eclipse RISC-V embedded ecosystem from chips to the cloud and beyond. Before we begin, please, I want to ask you to feel free to share your questions in the chat or using the Ask a Question tab, and we will go through together at the end of the session. Okay, so, and make sure to stay until the very end, because we'll be running a raffle to give away very good prizes, where a few lucky attendees will be win some prizes to the OCX. Thank you so much, and over to you, Frédéric. Thank you.
Of course. Thank you so much for the introduction, Lumina. Really.
No.
Wrong button.
Yes.
All right. Thank you so much. And thank you, everyone, for being here today for this presentation. Really, since this is appetizer week in a way for OCX, and OCX will take place in Brussels, I put myself in this Brussels mode. I drank 2 or 3 chimay before the presentation, so I'll be ready. Okay, maybe not, because with 2 or 3 chimay in my body, 1, I would make a bit less sense, and 2, of course, I would be an impersonator for Mannequin Piss, and this is not a good idea. All right, in any case, thank you for being here. And if you don't know about myself, well, essentially, I've been at the Eclipse Foundation for the last 6 years. It will be 7 years in February, managing various programs. And at this point, they encompass embedded and IoT. So in other words, everything that I will talk about today, I touch to it one way or another at the foundation. I've been around in the industry for a while, and feel free to connect with me on LinkedIn if you want to go further in conversations about anything that I will talk about this morning, or even Belgian beer, if you are so inclined. Really, I had the chance to live for 2 years in Brussels. If you've never been there, it's a great city, and I look forward to be there next April. And I hope that this particular presentation will give you, the impulse that you need to register for the event, or even to submit a talk, because that's certainly one affordable way to get in at OCX. If you are not into paying the conference fee, then you can get a pass if you are a speaker. All right. So one thing that I should mention, it's still semi-relevant. I wrote in 2022 a book which is an introduction to the IoT and embedded ecosystem at Eclipse at the time. In today's world, the half-life of technical books is really shorter than it's been, let's say, when I started my career and I had some hair on my head, but it's still relevant. So there are no mentions in there of ThreadX, but there is a discussion of open hardware and open source chips and things like that. And of course, a good introduction to the top 20 or 25 projects that we had in the Eclipse IoT and embedded ecosystem at the time. So please feel free to take a look or even purchase a copy. I should say, yes, I get a percentage of the sales on those ones, but it's really small. And I reassure you, I didn't get rich with that project. The intent was really to provide an easy to consume introduction to that particular ecosystem. And really, if there's one slide in this presentation that you should remember, if that's first one, the one currently on the screen, the goal there in this talk is to give you an introduction to each of those layers that make up our RISC-V ecosystem. And of course, when I say RISC-V ecosystem, of course, we support ARM, of course, we support other architectures. So the goal there is not to be exclusive to RISC-V, but we like to say that we have really a degree of RISC-V adoption at Eclipse, which is greater than anywhere else in the open source ecosystem. Apart maybe from RISC-V International itself, of course. Now, one thing to consider is that there are things that touch RISC-V at Eclipse that are not even covered in my talk. So for example, if you are a Java developer or no Java developers, well, the Eclipse Temuran project inside our Adoptium working group delivers RISC-V specific builds of OpenJDK, for example, that you should have a look at if you're interested at RISC-V in the data center. Okay, so although I cover most of it, it is really today from an embedded and IoT angle, and not from a comprehensive RISC-V angle. So don't worry, if you care about data center or other things like that, yes, Eclipse has something for you if you are into RISC-V technologies as well. But really, today the focus is on embedded and IoT by extension. And really, there are three things that we are trying to build in this RISC-V ecosystem around embedded and IoT at Eclipse. First, something which is vendor neutral. So although we have our own cores in open hardware and things like that, the goal is really to support anything and everything from a RISC-V angle. We are community driven, so this is not so much about large organizations, but really by the individual committers and open source contributors that are working on those various projects that I will discuss. And finally, we're trying to build something which is sustainable, and I should add sovereign, in the sense that, especially in embedded, when you think about it, more often than not, you are at the mercy of specific silicon vendors. You are at the mercy of the whims of commercial entities. And the goal there is to build something more sustainable, which means essentially, apart from the commercial interests, how can we have a set of technologies which can be built upon for the long term? And this means, for example, when you think about the RISC-V cores we have at the OpenHW Foundation, that since they are open source, you are not specifically dependent on any silicon vendor or any chip maker in order to get those chips made. Of course, getting a chip done is still an expensive proposition. I'm not trying to make this appear as more affordable and simpler than it should be. But at the same time, the existence of the RISC-V cores at the OpenHW Foundation and the fact that they are open source really lowers the barrier to entry to sovereign chip technologies in the market. And this is highly relevant when you think about it. Lots of car makers right now are discussing, or sharing the fact that some of their production is compromised right now because of chip shortages. So if you want to avoid that in your future, and if they want to avoid that in their future, looking at sovereign and sustainable RISC-V based cores like the ones at OpenHW Foundation is really a good idea. Anyway, so out of this to say is that we have a comprehensive RISC-V ecosystem starting from actual processor cores all the way to embedded and IoT cloud platforms to support those devices and everything in between. And really the goal of the presentation is to go through each and every layer on this first slide, in a certain level of detail. And we start with OpenHW Foundation. As I mentioned, we have a number of open source RISC-V cores and supporting technologies in there. And really, OpenHW Foundation is the world's only nonprofit organization truly focused on industrial grade or at least verified open source processor cores. Now, that doesn't mean that everything that we do is industrial grade. There are some projects which are earlier in their life cycle. But the goal is really to have something that you can pick up and then get actual chips made out of it. And when I say RISC-V cores, it's really that. So the main focus there is really on processor cores, although we have some platforms which are a bit more complete. So do not get in OpenHW Foundation thinking that everything is pre-assembled, everything is pre-integrated for you. There is still some work to do with your chip engineers, but at the same time, I mean, having such cores which are verified on our side by professional chip engineers is really something unique in the industry. And so if we have a look at a high level at everything that OpenHW Foundation is doing, the cores themselves are on GitHub, and they are written in a language called System Verilog. So if you're not a chip designer or chip engineer, System Verilog is a language that you use to really express the features and workflows inside the chip. And this is something that you can compile, that you can then verify, that you can simulate. And essentially, this is why the other things on this slide are so important. For example, we have a number of test benches for those processor cores, which essentially means that you can verify that one, they fit into the specifications from RISC-V International, because essentially RISC-V International are the stewards of the RISC-V instruction set. And that's the thing, RISC-V by itself, okay, was just an instruction set. So something you could use to implement a chip, but there were no actual cores coming out of that, because essentially the members of RISC-V International were working on such cores in the commercial space. So the goal there at OpenHW is to go one step further, not only to have the open source RISC-V instruction set at RISC-V International, but to have open source cores that implement it as well. And this is why the test benches are so important. And this is why the integration we have with several commercial tools for chip layout is so important as well, because when you work with a foundry and when you work with commercial chip designers, having support for those commercial tools is really important, because this is what they would be expecting other chip designers to work with. So we have licenses for some of those tools, and our verification engineers are using them in order to verify the chip and ensure that they are industrial grade. Of course, having a core or even a complete microcontroller, because we have such a thing in something called the CORE-V MCU. So that's an open source implementation using one of our cores. And then with open source peripherals, it provides a complete platform that you can run RTOSs like Eclipse ThreadX, for example, on it. And really, the support software is really important, because without software, a chip is a very expensive, useless thing, right? So the work that the OpenHW Foundation team does around support software and compilers is really, really important as an enabler, of course, for the rest of our Eclipse ecosystem. And of course, then there are ports of specific RTOSs and extensive documentation to support into the adoption of those various processor cores, or even the CORE-V MCU that we've got. So all in all, even if you're not a chip engineer or a chip designer by trade, the OpenHW Foundation can needs you if you have expertise with compilers, if you have expertise with real-time operating systems, because all of those things are enablers for the adoption of the OpenHW processor cores. And so if we look at the high-level roadmap for OpenHW, you will see that there are equivalent to the most popular embedded cores in the market. So we start with the CVE2 family, and the CVE2 is equivalent to the Cortex M0 or M0+. So very low power, deeply embedded applications that don't need tons of resources, but are, of course, highly useful. And then when we move a bit in the middle, we see equivalents to the Cortex M4, Cortex M33 cores. So that's where we have the CVE4 family, and there are several flavors of them. So some of them add specific features to address very, very specific market requirements. But in any case, if you look at the CV32E40P, okay, this is the core which is part of the CORE-V MCU. So it's a complete core that goes inside a more complete microcontroller in the case of the CORE-V MCU. And then we also have a number of cores that are more powerful, that are equivalent to Cortex M7, A7, or A55, for example, and that could be used in multi-core configurations as well. And that's the great star of our show, the CVA6 core, which comes in, once again, various flavors out of it. And actual commercial products have been shipped using that particular core. And then we see the little cousin of the CVA6, which is the CV Wally in the middle. So CVW means CV Wally. And the Wally core from Harvey Mudd College is, let's say, slightly simpler, but really it comes in various 32-bit and 64-bit configurations. It's highly modular. So from that perspective, depending on what you need to support, it can be an interesting alternative to the CVA6. But whatever core you contemplate there, you have the assurance that they've been looked at by professional chip engineers, that there's been serious verification efforts behind them. And so, that they are a good platform to start with for your own chip project. And from that perspective, it's easier than it sounds, in the sense that many of those cores can be run on FPGA boards, which means you don't need actual silicon, you don't need an appropriate FPGA, and then you can use the system Verilog, synthesize it for the target FPGA, and then add your own features, add your own extensions. And in the context of AI everywhere, this is highly useful, because essentially, given the modularity and extensibility which is built in the RISC-V instruction set. This means you can use the OpenHW Foundation cores as your general compute provider. So, we've done it for you, so you can focus on your next generation AI accelerator or whatever exciting technology you want to build on top. So please have a look into those technologies. They are really great. So in terms of the roadmap for the next year, some of those items have not necessarily formally confirmed and all of that, but I can safely say that most of it will happen. So right now we are busy refactoring our big CORE-V project into smaller projects. And the first one where this is done right now is the CVA6. And this means there will be distinct project lead and committers working on every of the cores that we've got, including CV-Wally and the CVE4 and the CVE2. We'll have a distinct and decoupled project for CVFPU, so essentially a floating point unit which would be reusable about cores, and we'll come up with something which is called an official TRL4 definition. And so if you're not a chip engineer, maybe you're wondering what TRL is. TRL stands from technology readiness level, and this is a kind of vocabulary we adapted from NASA. So essentially, the higher the TRL level is, then the closer to an actual market shipping product you are. And so this goes up to TRL 8 and 9. Typically, we target TRL 5, which is a good product which still needs to be debugged a bit before put into mass production. But having an official TRL4 definition means we'll be a bit more flexible about this. And so there will be a greater influx of projects that are not as mature, but maybe a bit more innovative in terms of the potential they bring to the table. And of course, the thing is between TRL4 and TRL5, there's a big gap in terms of the verification effort needed. So having an official TRL4 definition means that we'll be more accommodating of projects that still have a bit to do in terms of verification work to get to TRL5. And of course, our focus in the next few years will be not so much to have tons of new cores, but to have more people contributing and adopting the cores that we already have, because that's the thing. They are already great as they are, but they need more debugging. They need still more verification. They need to be integrated in actual chips, physical or not, that will make their way into the market. And our focus at OpenHW Foundation will be on that. Now, going one step further up, come real-time operating systems, because of course having the cores is one thing, but you need the proper software to do something with them. And really, Eclipse ThreadX has the distinction to be the only real-time operating system in the market right now, which is both open source and certified for safety-critical applications. So ThreadX is already available in 32-bit and 64-bit RISC-V versions, and it supports a broad array of Cortex cores, Cortex-A, Cortex-Ms, and all of that. And to be completely clear there, my focus today is on RISC-V, but of course, Cortex and ARM support in general is very important for our ThreadX community. So this will not vanish at all. We still aim to bring support for the latest versions of the ARM architecture and the latest ARM cores, etc., etc. So this is not going away. But certainly, we have a great emphasis on RISC-V in the ThreadX ecosystem. And the reason for this is simple. I mean, you cannot be fully sovereign if you don't have this combination of open source cores and open source real-time operating system on top. So there is a great opportunity for ThreadX in the RISC-V ecosystem. So ThreadX historically had been a commercial product. So if you're not familiar with it, it started in 1997, so that's quite a while ago. I had it on my head at the time, and it was a commercial product from a company called Express Logic. And for a long time, it stayed like that. And I must say that from a commercial perspective, it's been one of the most successful commercial RTOSs ever. which attracted Microsoft's attention at some point. And so they tried to get a shortcut in the embedded market in 2019 by purchasing Express Logic and renaming ThreadX as Azure RTOS. So maybe you've seen that name. For a number of years, Microsoft tried to make it happen and then made the decision to exit that market in 2023. But rather than kill the technology, because they could have done so, they decided to make it open source at the Eclipse Foundation. And this is how Eclipse ThreadX got started as an open source project. So in 2023, Azure RTOS became Eclipse ThreadX. And so in regaining its former name of ThreadX, the technology really got a full ecosystem to go around it at the Eclipse Foundation. And the great thing about this is that now ThreadX is available under the very permissive MIT license. So you can do whatever you want with the code without telling anyone. But of course, we would be delighted to hear from you if you are using ThreadX, building great things with it. And so next year, maybe as we get ready for OCX 27, you could be in my place giving this presentation and telling the rest of the community about the great things you built on top of ThreadX. All right, so what's in the ThreadX toolbox? If you're not familiar with the technology, where essentially there is first the scheduler itself. ThreadX is a high-performance real-time operating system coming in two flavors. There's ThreadX itself, and there's ThreadX SMP. So if you have several cores on your SoC, you can schedule threads on any of the cores available using the SMP version of ThreadX. Then we've got FileX. FileX is an embedded implementation of the FAT file system with optional fault tolerance and wear leveling. So we have something which is not shown on this slide called LevelX. And essentially, if you have SD storage, flash storage, and you want to make sure that the chip or SD card that you are using will live as long as it can, then LevelX will essentially make sure that all of the physical sectors on the storage device will be used in order to store the data, which means that essentially it won't fail as quickly as it should, without that kind of wear leveling. So it's really a great support, great feature for FileX in there. Then we've got the full USB stack, both in device and host mode, which means essentially you can build a keyboard running ThreadX, or you can build something that will plug the keyboard on running ThreadX, or both. No problem there. The questions, yes, you can ask them in the Q&A. I monitor the chat, but will answer any questions you have at the end of the presentation. So either type them in the chat or use the Q&A feature on Crowdcast, and I will be delighted to answer them at the end. Now, USB-X, so it can be host mode or device mode or both. And really is a very flexible solution. It supports a broad array of USB classes like video, audio, storage, and of course, human interface devices like mice and keyboards, all of that. Then NetX Duo is certainly one of the most interesting components that we've got. It's a full-blown IPv4, IPv6 network stack with several protocols built in, and TLS, DTLS support. So from that perspective, it's quite strong. One of the great things about NetX Duo is that it's very small. You can get all of those features in 50 kilobytes or less. And by the way, ThreadX itself can be quite small as well. So depending on the features that you enable, but essentially ThreadX itself, if you are using the non-SMP version, can be as small as 2 kilobytes if you need it to be as small. And then going forward, we've got GUIX. GUIX is a widget, a user interface widget library with a design tool that you can install on your laptop. It's Windows only for the time being, but in any case, you can use that tool to generate the user interfaces So it will generate the C code implementing the UI for your application. And GUIX is optimized for small size, as small as 14 kilobytes. So it's a very interesting proposal. And then there's ThreadX, which is a way to instrument in real time your ThreadX application. So if you want to debug, if you want to optimize the performance of the application, then ThreadX is a useful tool to provide real-time analysis of your system-level behavior. In terms of safety certifications now, I told you that ThreadX has the distinction to be the only real-time operating system which is both open source and safety certified. So you have the full details for our safety certifications there. So currently we are certified for IEC 61508 SIL4 in electronic devices, IEC 62304 safety class C for medical devices, ISO 26262 ACLD for automotive, and EN 50128 for trains. And of course, we are looking into DO standards like DO 178 for aerospace and things like that. We are not there yet, and this would require additional efforts from our team. But this is something that we are considering certainly on our long-term roadmap. And then we have a bunch of UL safety certifications on the other side for home appliances. So essentially, if you have dishwasher or microwave or washing machine from popular German brands, for example, at your home, or printers from a very large American supplier of such gear, then there is probably a chance that there is ThreadX inside. So up to now, ThreadX has been deployed in 12 billion, that's B, billion with a B, okay? So 12 billion devices worldwide, and still counting. Tons of companies are still producing ThreadX powered devices. So there's a chance you have ThreadX in your home already. And so to sustain the growth of ThreadX, what we've done is that we established something called the ThreadX Alliance. So if you're interested in sustaining the growth and innovation of ThreadX, really the ThreadX Alliance is the place to be. So please have a look at the website. You can become a member. And once you are a member, you can buy a subscription to our safety artifacts package. So if you want to certify for safety critical applications your own product and use ThreadX in that context, then ThreadX Alliance is the place to be. And all the details about our safety artifacts and all of that is on the ThreadX Alliance website. Now, the way this works is essentially the ThreadX Alliance is operated by a separate Eclipse Foundation operating company to isolate the commercial liability. And this is a subscription-based program that provides also marketing benefits. And if you're already a member of the Eclipse Foundation and its Eclipse SDV working group, then you can become a partner in the Alliance at no additional cost there. So please be in touch if that's the case, if you are not already a member of the ThreadX Alliance. Now, the way the safety artifacts licensing works for ThreadX, first, you have to understand that ThreadX is safety certified, but it is certified in what we call out-of-context mode. And what that means is that we don't certify it on a specific hardware platform. We certify it on a simulated Linux-based environment, okay? And this provides us the TÜV-SAR certification that you've seen on the previous slide. And then essentially you need to complete the certification of your own product on a specific hardware platform by yourself. But really, our safety manuals and other safety artifacts are a tremendous accelerator in getting your own certification done. And essentially, the great thing about our safety artifacts package is that it covers all certified versions of Eclipse ThreadX and all of the components. So ThreadX, NetX Duo, USBX, GUIX, all of that is in the package. And of course, this is not for redistribution to your own customers. So if you are yourself a supplier of safety certified components to other device makers, then they would need to become ThreadX Alliance members and get their own subscription as well. And there are various subscription modes per product family and corporate. I'm not covering that in greater detail today. Now, what is the roadmap for ThreadX? First, we started with our September release, quarterly release cadence. So which means every quarter there will be a ThreadX release publishing all the vulnerability fixes that we corrected during the quarter, and of course all the non-security related fixes that we deployed, plus new features as they come through our public roadmap. By the way, if you're curious about the roadmap, what are we working on as a team? We are managing our roadmap through a public project on GitHub. So you have the link in the slides, and those slides will be shared along with the recording later, once the team publishes everything on YouTube. So, but essentially, if you go to GitHub/Eclipse ThreadX and you go to the projects section, then you will be able to find that project and see exactly what we are working on. In terms of safety certification, we expect to start the certification process for the ThreadX 6.4 series later this year. And really our focus for the 6.5 or 7 releases, we're not sure exactly what comes next, but essentially we want to expand our hardware support. So we have commitments by STMicro, Texas Instruments, and others to do so. We want to keep NetX Duo up to date with newer versions of the protocols in there and get support for example, MQTT version 5, but also more homegrown Eclipse innovations like Eclipse Zeno and new protocol. We want to fill some gaps identified by our software-defined vehicle community. And really, we want to deprecate some orphaned components like Azure IoT and maybe GUIX, because right now, GUIX is a comprehensive solution and it works. However, we don't have in our core committer team anyone working actively on this, so it's more in maintenance mode. And at some point, well, if no one steps up, we have decisions to make. So if you're really passionate about embedded user interfaces and want to contribute to keep GUIX alive, please come to us and get involved in GUIX. Okay, enough about ThreadX, because of course, whether you use ThreadX on some other RT OS to build your embedded and IoT project, you will need some developer tools. And here at Eclipse, of course, everything started with developer tools in 2004. So it's over 20 years of innovation in that space. People still closely, of course, associate the Eclipse Foundation with the traditional Eclipse IDE. After more than 20 years, it's still going strong, millions of users and all of that. And many embedded vendors have their own solutions built on the traditional desktop Eclipse IDE, or more specifically, the Eclipse C development tools version of the traditional Eclipse IDE. But, of course, the market still evolves, and tons of people love Visual Studio Code, for example, in the embedded market. It's a good thing, but at the same time, it's a bit annoying to see this mandatory Copilot button in there. And it's a bit annoying to see the forced GitHub integrations and all of those things coming in Visual Studio Code right now, including Copilot integration, which is once again forced on users. So really, the Eclipse Theia project provides technology building block for next generation IDEs that shares its underpinnings with Visual Studio Code, but removes the bad parts, so to speak. And really, it's a fantastic platform, as you will see. And the Eclipse Theia project comes, as a pair with the OpenVSX project, and really OpenVSX is a vendor-neutral, community-owned repository for VS Code compatible extensions. So from that perspective, if you don't like the fact that Microsoft is watching everything that you do, everything that you are installing from the Visual Studio Code extension store, then OpenVSX is for you, because essentially we don't do monetization on our users. It's really vendor neutral, community driven. So there's a little distinction there when we talk about Theia IDE, which is an actual IDE that you can use, and the Eclipse Theia project, which is a platform to build IDE-like tools. And really, if you're into the tool market, if you want to build a tool, then Theia is really your starting point. It provides you all the components you need to build your own tools. And if you're an embedded end user, then Theia IDE is a good starting point. It's really a browser and desktop-based IDE that you can install on your laptop or run on a website. And really, it comes with AI features, but those are yours to configure. And really, a good incarnation of this principle is what you see on the screen. So this is a screenshot of Eclipse CDT Cloud Blueprint. So CDT Cloud Blueprint is Eclipse Theia IDE pre-configured with tons of embedded and C development tools and extensions pre-configured for you. And from that perspective, if you look really closely at the screenshot, you will see that there's no Copilot button in there. There's no AI button at all or AI chat enabled. However, if you want to bring AI to the IDE, then you can do so, no problem. But then you choose whichever agent to integrate on your own. And from that perspective, there will be this week in our OCX webinar series, I think a few presentations on Theia and all of the other tools in that particular ecosystem. So please catch those presentations for more details specifically about that. But really, if we dig a bit deeper at the way that AI is integrated in Theia, you can have a code completion agent, you can have a terminal agent, you can get even your own custom agent in there. And of course, chat agents that are pre-integrated, from popular options in the market. So if you want Copilot back, you can. If you want ChatGPT, you can. If you want Gemini, you can. If you want whatever, Claude or some other. Really, the great thing about this is that you are the one making the decision about what level of AI should be in your tool, okay? And what agents should be the ones helping you out in your daily work. So nothing is forced on you. And if for whatever reason there's a new hot AI agent, it's not pre-integrated, you can easily integrate it yourself in the tool as well. So from that perspective, it's a very clean design, which in turn makes you the developer, you the end user, as the one deciding whatever will be offered in your own IDE. And of course, having developer tools is nice, having an RTOS is nice, but there is much more to that from a device management and cloud platform perspective, because essentially you need tons of supporting platforms for any serious embedded and IoT project. And really, the application building blocks we have in Eclipse IoT and Eclipse SDV are tremendous toolkits for you to leverage. So from that perspective, Eclipse IoT is really a set of building blocks to implement commercial IoT solutions. And Eclipse SDV, of course, is more targeted at software-defined vehicles, but there are tons of very generic technologies in there that you can use for more generic embedded and IoT projects. So whether you are an SDV engineer or not, and of course there will be dedicated automotive presentations later in the week in this OCX webinar week as well. Please have a look. But essentially, Eclipse SDV is another ecosystem to have a look at in terms of getting tools that are relevant to embedded and IoT. So this is our handy-dandy Eclipse IoT reference architecture that we use at Eclipse IoT to, have a common reference point when we have conversations. It's not perfect, maybe it's different from your own vision of the world, but really the goal of this is not to go over all the little squares on this slide in detail, but really to impress on you that we have a comprehensive ecosystem with tons of projects in every category, right? Of course, from a development tools standpoint, we see that on the left. I talked about it already, but nearly every other category has multiple entries in there. And of course, it all starts with OpenHW Foundation hardware and cores. But then we have tons of protocol implementations. Some of them, like CoAP, DDS, MQTT, are very popular standards in the industry. And some others, like Eclipse U Protocol and Eclipse Zeno, are homegrown Eclipse innovations. And really, it's interesting to see the contrast in those various communities. Then if you look in the middle, you've got a bunch of things for edge computing, from orchestrators, in particular Eclipse Ankaios, Eclipse Bluetooth, Eclipse Canto, Eclipse Symfony are all great orchestration solutions that you can leverage. And then from an operating system perspective, we have two. So we have Eclipse ThreadX as a real-time operating system, which is really lean and mean, really optimized for very small size, as we've seen earlier, and of course performance. And on the other side, we have a more complete solution in Eclipse Oniro. Oniro is really something you would run on a smartphone or tablet. So once again, if you're anxious because Android, for example, is increasingly a single vendor ecosystem driven by Google, then of course looking at Oniro would make sense, because this is an actual vendor neutral project trying to build technologies that are relevant to smartphone, tablets, or other home devices that would require more, let's say, more powerful user interfaces than what you would be able to build on the top of ThreadX using GoEX, for example. Anyway, all of this to say is that this is a comprehensive ecosystem spanning over 50 projects. And if you're not sure about how to navigate this, there are two things. First, most of those projects have been covered in my book. Not all. Maybe I'm due for a second edition. But in any case, if you're not sure where to start, if you need some advice, please feel free to contact me, and I will help you out to figure out what could be relevant to what you're trying to build in this ecosystem. And in particular, we've got the Eclipse Edge and the Eclipse LMOS projects in the machine learning category. So really, even from an AI perspective, there are tons of interesting things happening around AI and machine learning at Eclipse. And I think we have an Eclipse LMOS presentation later this week, and that one is interesting. It's a framework to build agents, which comes with its own agent definition language. So if you want to see a very interesting take on AI agents to build your own, then certainly Eclipse LMOS is a very interesting project to look at. And then our SDV community, as always, tons of things happening and tons of relevant projects for you as well. So you see LMOS there, you see Ankaios and Symfony there. They started in our SDV community, but they are generic orchestration solutions that make sense on any edge device, really. So from that perspective, please have a look. Of course, Eclipse Zeno is in there, Eclipse ThreadX, but there are tons of original vehicle-specific projects in that ecosystem. And I'm not spending more time on this. I'm not the experts. The experts will be there later in the week. But in any case, please have a look at those projects. And I would highlight, in particular, the TSF project that we see there at the top, which is not a technology project, but rather a kind of methodology project. So TSF stands for the Trustable Software Framework. And essentially, it's a next generation process to get projects safety certified, or at least in a safety certifiable state. And the SDV community is paying tons of attention to this. And the intent is for Eclipse ThreadX to adopt the TSF methodology as well to support its future certification efforts. So please have a look at TSF, because if you care about safety certified, this will be relevant not only to our software-defined vehicle ecosystem, but for the broader software or safety certified software solutions community at Eclipse. And so in SDV, one of their particularity is that they have this notion of integration projects, which essentially means that other projects are working on their things, and then they have a common set of artifacts or guidelines to work towards. And so an example of this is the Eclipse SDV blueprints projects. So really, the blueprints are just that, right? They detail an architecture mixing and matching various Eclipse SDV and non-SDV technologies together to implement really specific solutions for specific use cases. So really, if you are looking for inspiration or looking for pre-made starting points for products, that could be a good project to look at. And then we have the Eclipse Safe Open Vehicle Core, or S-Core project. And Eclipse S-Core is really a project working on requirements shared among the various software components, processes, tool chain, and integration gates. And really, this means that independent projects come together to form this more comprehensive framework to support a variety of SDV use cases. So please have a look there, because, of course, this could be an approach we could adopt, for example, in our IoT ecosystem as well, to have a kind of integration project. That means that projects on a lower level work together towards more integrated goals. And finally, for a long time, Eclipse, the Eclipse Foundation was about code and just code. And then in 2018, we started doing specifications. And now we have reached a point where we are involved in specifications and standards. And from that perspective, it's really fascinating what's happening. Because, of course, this got us involved at Eclipse, gradually involved in international standards as well. So, for example, now it's possible to take an Eclipse specification and make an international ISO IEC standard out of that as well. We already done that with Eclipse Sparkplug, which is a protocol that goes on the top of MQTT and provides interoperability in the MQTT environment. So Sparkplug became an ISO IEC standard, and it was the first in doing so. So now it's also known as ISO IEC 20237, which is a fantastically romantic name for it. In any case, our data space people and other Eclipse communities are working towards this goal of making Eclipse specification as international standards. But now, of course, with the CRA looming in Europe, then we needed to go further than just standards. And really what we did in that space is really something fascinating. We created a specific working group, which is called the Open Regulatory Compliance Working Group. And the goal there is to come together up with other open source communities like the Rust Foundation, the Python Foundation, etc., and really come with a common set of processes that then can be implemented in open source projects to simplify compliance to the CRA by the downstream consumers of those technologies. Okay, and this is really great because essentially this means now Eclipse has an open relationship with EU regulators and legislators, for example, to validate that our interpretation of the regulations around the CRA and other upcoming legislation and regulation is correct. And so really the goal there is through education, thought leadership, and process specifications, make sure that the Eclipse community and other open source communities are ready for the CRA. And if you care about the CRA, you should be a member of that particular working group. It's really an important one. But when we take a step back really and see the involvement of the Eclipse Foundation from a spec and standards involvement, it's really about two distinct sets of requirements. There are the regulatory requirements coming out of the CRA and other legislation that will come up. And this in turn will translate into open source specifications. And then there are specific working groups like the Sparkplug working group and the Data Space working group coming up with market requirements that are then implemented in technical specifications that can then become standardized through ISO IEC GTC1, for example, because we have the relevant status to do so with ISO IEC GTC1. And then there's the certification aspect. Since ThreadX, for example, is certified against ISO and IEC standards, then we are closing the loop and essentially getting some of our other technologies certified for compliance against specific standards. So you see, specification and standards at Eclipse are, let's say, at the core of everything that we do. And this is true from an embedded and IoT perspective, given the fact that ThreadX is certified. And of course, if you are a device maker that needs to comply from the CRA, you have the assurance that our security team and, of course, whatever processes will come from our open regulatory compliance working group will help out, in your own compliance efforts. And that's it for this particular talk. So I hope that this brief and yet fairly long introduction to our embedded and IoT ecosystem was to your taste. Really, I would encourage you to register for OCX 2026 at this point, because essentially there will be a track dedicated to embedded IoT, edge computing. So if you want to learn more about several of the technologies I mentioned in my talk, OCX is really the place to be. And of course, there will be an open hardware track as well. So if you're more of a chip designer, so please register as well. There will be specific content that will be relevant to you. And this will be the opportunity to come together face to face. So I intend to be there and to participate in activities on both the hardware side and the software side. So please make sure to register. And if you're a potential speaker, well, the call for proposals is still open. It will be open till November 15. So if you want to get in on the cheap, just to have to pay the hotel and travel, but not the conference pass, then being a speaker is absolutely the best way to achieve this. And plus, I'm so popular now that I've been an EclipseCon and OCX speaker. It completely changed my life. So if you want to be popular, be recognized in social events and all of that, then being an OCX speaker is certainly the way to be. Okay, maybe I'm exaggerating a bit there, but in any case, we are looking forward to see your submissions, and you be featured as an OCX speaker as well. So thank you so much for listening to me this morning. And now let's have a look to see if we have any questions that I didn't answer.
Thank you so much, Frédéric, for this insightful presentation. Yes, let's take a look to the questions. So I can see one from
in the
Marshall.
Chat. Yeah, exactly.
Yes.
So thank you, Martial, because I suppose this is a French name in any case. So your question is about various compliance to guidelines from MIDI, ICL, automotive, nothing about aeronautic. As I mentioned, we are looking at anything aerospace related, but of course, the level of work required to be compliant to aerospace standard is one notch above what it would be for IEC 61508 or automotive in ISO 26262. So I would be completely frank there. We are not ready for that yet, but certainly this is our longer term roadmap because, of course, especially with TSF as our methodology, the goal is to be as stringent as we can be to ensure that we can be compliant to ever more stringent standards. And by the way, if you are interested in aerospace, I've seen around Open Hardware something really interesting. I was at RISC-V Summit, North American edition back, I think it was 2 weeks ago. And from that perspective, it was interesting because we had a demonstration from one of our Open Hardware Foundation members, the University of Saskatchewan. And what they were showing, by the way, I'm a Canadian, Saskatchewan is familiar to me, maybe not to you. So Saskatchewan is a Canadian province. And so essentially in that province, they have this university in, I'm not sure if they are in Saskatoon or Regina or both. So I'm a bit uncertain there. But anyway, out of that to say is that University of Saskatchewan is a member of OpenHW Foundation, and they were demonstrating something called Star RISC. And Star RISC was literally our CORE-V MCU in a version designed to be hardened against space radiation. And so they did that without using a chip process that would be radiation hardened. So essentially, they made the transistors a bit bigger in their design, and but still were using our CORE-V MCU open source design for the microcontroller. And essentially, the goal there is to get 90%, let's say, of the benefits of radiation hardening, but without a very expensive space-oriented industrial process to make the chip. And that was really exciting because it was a real chip running a real demo, and they will send it in space in 18 months. So if you care, Martial, about aerospace in general, well, the open hardware community has aerospace-minded people. And of course, the Eclipse ThreadX team is also very interested in aerospace applications. So we are not, let's say, ready to get it certified again, DO 168 or other standards like that. But we aim to eventually do that in a few years. And the other thing to consider is that ThreadX has been already deployed in space probes instruments. I think it's on the Mars Reconnaissance Orbiter or something like that mission that has been used in very specific instruments. So ThreadX went to space, maybe not in a DO 168 capability, but in any case, it's good enough for space probes. And so we should probably have a talk to see how we could get you involved, Martial, and see how we could get faster to compliance to the standards you care about. So please be in touch and feel free to reach out on LinkedIn. And then you asked two other technical questions. What are the available APIs? And so we have our own APIs in ThreadX. So it's a complete custom API, because that's the thing. ThreadX, and that's something I didn't mention, is completely self-contained, which means there are no third-party dependencies in there at all. The TLS layer, the cryptography, everything has been built from scratch by the team. And so this means the software bill of materials is very simple. It's ThreadX. That's all. And so in terms of third-party APIs that we implement, however, we have a POSIX compatibility layer. So essentially, it's possible to use the pthread APIs inside a ThreadX application to reuse existing code, for example. So once again, this could be the topic of a presentation. And so maybe I should submit another one for OCX delving on that particular topic. In any case, we have POSIX compliance in there. And we have also a FreeRTOS adaptation layer. So if you have FreeRTOS compliant code in there, then you can port it more easily to use ThreadX. And so swap FreeRTOS, which is not safety certified and even doesn't have production quality memory allocation in its open source version, for something a bit better, aka ThreadX. And then, is there any hypervisor feature? No, we don't have a built-in hypervisor in ThreadX right now. Of course, if you are interested in contributing one, that's something we could consider. And if not, I would be interested in knowing which hypervisors would be relevant to you, Martial. So once again, we need to talk. So I hope that answered your questions if you are still online.
All right. Thank you so much, Frédéric. Do we have any more questions? Let me check. I don't see. Oh, yeah. Okay. He's saying yes.
All right.
You answer his questions.
I'm glad.
All
I'm
right.
glad I was able to answer.
Yeah, thank you so much, Frédéric, for once again sharing your expertise with us today. And now, as I promise it's time to our raffle giveaway today.
Oh, nice, nice.
I already upload the list of attendees on the raffle website, and the system will randomly select our winners in live on screen. So good luck,
Exciting.
everyone. I will share my screen now. Just a moment. Okay, can you see the screen?
Yes, we can.
The first prize will be a free OCX 2026 ticket, and the second and third prize is €50 OCX swag shop voucher. So before any further delay, okay, I will put confirm and then it will select the winners.
So let's see what we've got. Good luck, everyone.
Good luck. Oh, look at this. Okay.
And then Martial got
Marcial,
a reward
yeah.
for his great questions. So I'm glad to see that.
Yes. Congratulations.
Congratulations
And
to our three
Sarah
winners.
and yes. Our team will contact you so how to process your prices. All right. Thank you everyone for being here today. I will stop presenting now. Okay. And thank you so much for this webinar, Frédéric. And thank you all for attending.
It's been fun, and I look forward to meet at least some of you at OCX 2026. And if not, well, we'll have other, of course, virtual events and things like that. So please stay in touch, subscribe to the ThreadX or Eclipse IoT or Eclipse SDV mailing lists and all of those things. Subscribe to the LinkedIn pages. Typically, we announce a lot of things through LinkedIn as well. So in any case, don't be strangers. And see you next time, whatever that next time would be.
Thank you. Have a great afternoon. Bye bye.
Yes. Have a nice rest of the day, everyone. Take care.